Section 3.2, zeros of polynomial functions. So we're going to take a look today at going a little bit beyond quadratics, which we've already been doing before, right, where we factored things that are equal to 0 and solve. And we're going to be looking generally at polynomials. There's a couple of theorems here at the beginning. I'm never going to make you write the theorems out, but you need to know what they are. Otherwise, if I ask you to use them, you won't know what it's talking about. So the first theorem is called the remainder theorem. The remainder theorem says when a polynomial, p of x, is divided by x minus c, right? Like if you try to factor x minus c out, would be the idea. The remainder, the part that wouldn't factor, is p of c. And I'll show you how we're going to use all this in a minute. Just write them down for now, okay? So that's the remainder theorem. Going hand in hand with that is the factor theorem, and it says that the x minus c actually is a factor, then, of the polynomial p of x, if and only if c is a zero of y equals p of x. Or, equivalently, you could write p of c equals 0. So if the remainder is 0, if p of c is 0, you have a factor.
X minus c.
All right, are we good for me to switch to the next screen? Not quite? Okay. Okay. Everybody else good? Not just Maxwell? Yeah? All right, that's good. All right. Okay. I think probably not. Okay, so first is show of hands. I'm not going to ask you to tell me what to do or how to do it. I'm just curious, show of hands, how many of you have seen synthetic division before? Okay, so maybe half. All right. So it's one of those topics that's sometimes covered and sometimes not. That's why I ask. And so synthetic division is very friendly, and I'd like to show you how to use synthetic division to find the quotient and the remainder. So I'm first going to write down what we would do if we weren't using synthetic division so that maybe you can at least a little bit appreciate why the synthetic division makes life easier. If we were doing this with what's called long division, you know, like back in second grade when you first learned long division, we would write x minus 4 on the outside. And we would write x squared minus 3x plus 9 underneath. And then we would start looking at what I need to multiply things by and so forth, just like if you were to divide two numbers. This is what long division would look like. It's just messy looking. When you're doing synthetic division, what you do instead is you deal with only the numbers, the coefficients. So first, I need a column for each variable piece. So like I need an x squared column, an x column, and a number column. That is not a hashtag. Okay? And what I do is I put each of the coefficients in that particular column. So there's a 1 in front of x squared. So I'm going to put a 1 underneath the x squared. There's a negative 3 in front of x. So I'm going to put a negative 3 here. And then there's a 9 coefficient at the end. Okay, so far so good? Everybody sees where all the pieces came from. Over here on the outside, in sort of a box just to separate it, visually speaking, we're actually going to put what happens if I were to set this equal to 0 and solve. So if I set x minus 4 equal to 0, I'd add 4 to the other side, and I'd get x equal 4, right? So I'm going to put a 4 on the outside. Okay, all good so far? All right, here's what you do. We're going to draw, there's going to be a space underneath there, but we're going to first pull the number 1 down. We don't do anything but just pull it straight down. So step number 1, pull the number straight down. Step number 2, we multiply this number by the number on the outside, and what do we get? 4. And we're going to put a 4 underneath the negative 3.
I've done this before.
Okay, good. All right, so the arithmetic is pretty straightforward because you're just dealing with, right, in this problem anyway, at least integers, right? We're not doing fractions or decimals. It's not ugly stuff. And then what you're going to do is as you move down the column now, you're adding. So negative 3 plus 4. It would be positive 1. And then we do it again. So now again, I take this number 1, multiply it by the 4 on the outside. That gives me 4. I write it under, good grief. Write it under the 9. Still messed it up, but I hit the right button. There we go. And then again, we add down. So we get 13. I'm going to box this 13 in, and we'll talk about the pieces that happen at the bottom. What do we have? Okay? So we're done with all the mathematics. We're to the point of like interpreting, what did that tell me? What did I get out of this thing? Well, this right here is the remainder. Okay, so like right back in like elementary school when you did division with remainders, you'd write R1 or whatever. This is R equals 13. It's your remainder. Right here, these are the coefficients of your quotient. So let me show you what happens. My original columns were titled x squared, x, and number, right? Well, as I do my division, I lose one of the powers. So at the end, what happens is I have 1 power less. So since I started with x squared, this is now x. And I started with, after the x is my number. So what I end up with here is 1x plus 1, or you could just write x plus 1. Now, it didn't actually ask me to write this out, but I want you to see what you have. I mean, like you have this other random piece. What does it mean? Because other problems will ask you. Your quotient is x plus 1. Your remainder is 13. Now, there's actually a step that you can do to confirm that you didn't make any mistakes. You can actually take the number 4 and plug it into the original equation. And if you did your synthetic division right and you do your evaluation right, you should end up with the same number 13. So go ahead and try it. Grab a calculator if you want. Do 4 squared minus 3 times 4 plus 9. Yes, ma'am.
So for this problem, is the quotient 1x plus 1?
1x plus 1, or you can say x plus 1. Mm-hmm.
Okay, in my math problem, will it ask for like the 1x plus 1?
It won't matter. It won't care. And this problem didn't actually, oh, it did actually ask us to find the quotient. I totally misread that. Find the quotient and the remainder, yeah. So my quotient is right here. I just looked at too little of the question, and my remainder is right here. All right, let's confirm that remainder though. When you plugged in the number 4, did you get 13?
Yeah.
Yep. So that's your check step, and you can make sure that you didn't make a mistake. If you did end up with a different value, you should double check your work in one area or the other, or maybe both, to make sure that there's not an arithmetic mistake.
Yay.
Okay, make sense?
No.
Okay, so what this actually calculated was, I don't know that I have a way of written it, I haven't, but this is like evaluating f of 4. We'll call it as though the function's name is f of x. This is f of 4. So the reason I mention that now is because the next question uses that notation. This one actually says to find f of -1 using synthetic division. So we can confirm the answer we're about to get by simply plugging in -1. In fact, let's just do it first so we know the answer that we're anticipating, okay? So let's plug in -1. So if I do -1 cubed minus 4 times -1 squared plus 8. What will I get?
For your final answer.
Mm-hmm. Is it 5? I think it's 3.
I'm really slow.
It's
Yeah,
okay.
I'm really
I
slow
think
at my math, so.
I think it's 3. We have a -1 at the beginning, we have a -4 in the middle, and we have our positive 8 at the end. So we should be getting 3. Okay?
I got
Did you get 3?
Oh, I cubed it. I squared it, so cubed it.
That'll do it. Yeah. Okay. All right, so we're expecting when we do our synthetic division here in a moment that we're going to get a 3. Now there's something interesting that happened on this problem that didn't happen on my previous problem. I have x cubed, I have x squared, and I have a number. What's missing?
An X.
An x. So I don't just get to skip that column. I need a column that represents it even though I don't have any numbers in that column. So as I'm sort of creating my columns, I need to make sure I still have an x column. It's just that I have a 0 in the x column. Okay? So I do need that placeholder 0 in my x column for this to work. So I have a 1 x cubed,
-4.
-4,
And an 8.
and an 8. And it's wanting me to evaluate with this number -1, which means the -1 is what goes on the outside. So, first thing, pull the 1 down. All right, what's my next thing?
Times 1 and negative.
Yeah, 1 times the -1, which gives me -1. So underneath my -4, I have -1. If I add down, what do I get? -5. What will I do? Times -1, which gives me +5. Adding down, I get 5.
And negative 1 will be
So you have -5. And then 3, which was what we expected to get, right? Yeah, so we did it right. Notice, you would know if you had an error. If you tried what we did at first, like where we just said, what do I expect to get? And you forgot all about this x column. Like let's just say you did this, where this piece was gone. And so you just listed it like this, right? Here's what would happen. You would have gotten a +5 right here, which would have given you a 13 right there. And you would know, I made a mistake somewhere because 13 is not the number I should have got. I should have got a 3. So that's when you would go back and you would check and say, okay, what did I do wrong, right? Hopefully you would notice somewhere you missed the x column. You have to have a column for every power of that variable. All right. These first 3 questions are 3 questions asking you to do the same thing, but in different ways. The first question says, use synthetic division to find quotient and remainder. The second one simply says, find f of -1. And then the third one says, is -1 a 0? But they're all asking you the same thing. They're all saying, use synthetic division and see what happens with the remainder and or the quotient if the problem included that part. So the -1 here goes on the outside as well, because it says it wants to know if it's a 0. And then I have columns for each of my powers of x. There's an x cubed, an x squared, an x, and a number. So I have 3, 2, -2, and -1. Okay, so far so good? So what do I do first?
You drag the 3 down.
You drag the 3 down.
And then you multiply 3 and -1 to negative. Add those together to get -1.
Good job.
And you multiply those two, -1 and -1 to get 1.
Right?
Add those two, get -1.
Good.
And multiply -1 and -1, get 1. And add those together, which would be 0.
Perfect. So this number is the remainder. We already have established that, right? This is r equals 0. Now, if you look back at the factor theorem that we did at the very beginning, it says x minus c is a factor of the polynomial if and only if c is a 0 of y equals p of x. C being a 0 means it has a remainder of 0. And that's what we just got. We got a remainder of 0. So is -1 a 0? Yes. The answer is yes, and all that work supports that answer.
So for the one we did before this,
Mm-hmm.
is, like, I guess the final answer would just be the remainder?
Yeah, this one just said, well, it just said find f of -1. So f of -1 here was just 3. This is all messed up because I was showing you something else. But yeah, we got f of -1 equals 3 using synthetic division. Over here, we also, what we got, and actually let's just check it so you can see. If I plug -1 in here, I should get 0, right? Because the remainder is 0. Those two go hand in hand. So 3 times -1 cubed plus 2 times -1 squared minus 2 times -1 minus 1, like that. So this is -3. This is +2, +2, and -1. 0, right? Mm-hmm. Yeah. So it does, in fact, equal 0, looking at it from both of those perspectives. So we can do that as a check step each time. Okay. Another question asking basically the same thing. I realize it's not exactly the same, but the process that we're using on all of them is the same thing. It wants to know, is x plus 5 a factor of x cubed plus 8x squared plus 11x minus 20? So this is much like the very first problem over here, where it says x minus 4 here at the end, right here. And what we had to do is we had to actually set it equal to 0 to find the value on the outside of the synthetic division, right, the corner value. So we're going to do that here as well. If I were to set x plus 5 equal to 0, and I subtract my 5, x is -5, right? Mm-hmm. Okay. So my -5 goes on the outside. And then I have a cubic, so I have x cubed, x squared, x, and a number. So x cubed is 1.
Squared is 8.
Mm-hmm.
And then x is 11. And your number is 10.
Right. Okay, so we're ready to do the synthetic division with this. We'll pull our number 1 down. 1 times -5 is? -5. 8 plus -5 is 3. 3 times -5. 11 minus 15. Good, -4. And then -4 times 5, -5. 20. What does it do? 20. So I get the 0. Okay, good. So is it a factor?
Yes.
Yes. And the reason is because the remainder equals 0. So yes, it's a factor. Yes.
If it has a remainder, is it a factor or?
No.
Okay.
If it has a remainder, it's not a factor. Think about what we mean when we say that 2 is a factor of 8. It's because it divides it evenly with no remainder. So the same thing's true for polynomials. Yeah. Okay. Part B we haven't done yet. It says factor completely. Everything that we've done so far has kind of stopped with what we did on part A. Now, I did show you back on the very first problem what the quotient is that we are left with, right? The quotient we are left with here would be 1 degree less. So this says x cubed, so it'd be 1 degree less. This one would be x squared, x, and a number, right? Okay, now we just established that x plus 5 is a factor. So what that means is that it has parentheses around it, and the other part, the quotient, is in the other set of parentheses. So I have 1x squared, or you can just write x squared, plus 3x minus 4. Okay? And if you wanted to make sure that you're right, you could multiply this back out. And you should end up with the x cubed plus 8x squared plus 11x minus 20. Right? That's what has to be true. Otherwise, there's a mistake somewhere, right? These two have to multiply to give me what I originally began with. Now, what the problem is asking me to do is not to multiply it back out. That would be like a check step if you wanted to do that. What it's asking me to do is to finish factoring this, which is a quadratic. And you know how to factor those. We've been doing those for most of our semester together. So this is x plus 5. This is 2 parentheses. I have x and x to get the x squared. The sign here at the end is negative, which means I need a positive and a negative. I need two numbers that multiply to 4 and add to 3. 4 and 1. So where do you want to put what, Damaris? 4 first? Fabulous. And we'll check to make sure that we have the right sign. So this is positive 4, negative 1. That gives me positive 3. So this is the correct ordering of them. And this would be the completely factored form. That's it. So part B is really taking the results from part A and then finishing the factoring that you already know how to do anyway. Okay? I have another theorem for you. This is called the fundamental theorem of algebra. Anytime somebody puts fundamental theorem on something, you know it's important. I have a fundamental theorem of calculus that I do in my calculus classes. I have a second fundamental theorem of calculus that comes at the end of Calc 1. Fundamental theorem of algebra in my contemporary math class, and in one of my elementary ed math classes, I have one called the fundamental theorem of counting. So every time we put these words fundamental theorem on there, they're important. The fundamental theorem of algebra says, if p of x is a non-constant polynomial function, okay, so it can't just be a number. It can't be p of x equals 7. It's got to have some variables in there. Then p of x has at least 1 0. So there's at least one value that I could put on the outside corner of the synthetic division and work it all out and get 0 at the end. That's what that's saying. It may not be the one they give you, but there is one that will work for every polynomial function, at least one. The rational zeros theorem, which is very long to write out, let me read it to you though. It says for a polynomial function p of x with integer coefficients, which is what we deal with mostly, all possible rational zeros of p of x have the form p over q, where p is a factor of the constant term p of x, and q is a factor of the leading coefficient of p of x. So I'm going to pause and just let you guys write those out for those of you who are writing all the details down because you don't have a printer right now, and make sure you have that chance to have that down. I'd like to point out the difference between these two statements. The first one, the fundamental theorem of algebra, is an existence statement, right? It says one exists. It doesn't say what it is. It doesn't even say it's real. Did you notice that? We're about to get back into those imaginary numbers. So it's not even ensuring you that you have a real answer. It's just saying there is an answer, right? There is a solution that you can find. The second one's actually talking about a specific type of solution and when it happens. It's talking about rational solutions. So rational solutions are fractions, decimals, whole numbers, integers. All those numbers are rational, okay? And it's telling you specifically what options exist for that solution when it exists at all in that form. So what I would like to do first is just go back through the 4 examples we have so you can see where these numbers that it's referencing in this second one, the really long theorem, are coming from. Because this is one of those places where I feel like our descriptive English fails us. This is super wordy and you still have no idea what it told you, do you? And it's really not hard to show you what it's doing, but it's really hard to describe in words. So we're going to go back to the very first example we did, problem number 1. And I'm going to clean off at least my highlighting part for my equation. This is my, it's an expression actually, x squared minus 3x plus 9. We know that 4 is not a 0 because I didn't get 0 as a remainder when I did it, right? But according to the fundamental theorem of algebra, there is some answer that exists, right? It may or may not be real. It could be imaginary, so that's a possibility. But if it's real, if it's rational specifically on that second theorem, here's what it says I should be able to do. The number that's the number at the end, just the constant term, and the number in front of the first term, the leading coefficient term, form a ratio. So we will call the numbers in front of x our p-values, and it's the factors of it actually, and the factors of the number at the end are q-values. So p is really nice because it's just a 1. If you have 1, the only thing that evenly divides 1 is itself, and it's negative. The number 9 at the end is divisible by 1 and 3 and 9. So it has 3 options. Okay, so the numbers in front of the first term we're going to find all of our factors. There's always pluses or minuses. We take the number at the back, we find all of its factors, pluses or minuses. And then what we do is we do a ratio. We write p's over q's. So mind your p's and q's, right, like that. Plus or minus, I'm just going to put it out in front completely. And then I'm going to put all these numbers, there's just one of them. Actually, I think I just wrote it upside down. No, I didn't. Okay. And then all the numbers at the end, 1, 3, and 9. So what does that really mean? Well, it really means that it might have a 0 at 1 over 1, or negative 1 over 1, or 1 over 3, or negative 1 over 3, or, I'm out of space, 1 over 9, or negative 1 over 9. If it has a rational 0, it's going to be one of those 6. They are the only options. And you might feel like, well, that's a lot of options, especially because the numbers weren't very big. I mean, 1 and 9 didn't have a lot of factors to begin with, and that's true. 6 options is a lot of options, but considering you started out with infinity options, it's not very many. Does that make sense? So we could do the same thing with our next equation. We'll do it again, okay? So here's my values on this one. My p-values at the beginning, again, are still 1, because the number at the beginning of this is still a coefficient of 1. Q at the end, though, is 8. 8 divides by 1, and what else?
4 and 2.
2, 4,
And 8.
and 8. I usually write them in order. You don't have to, but those are all of our options. So the possible rational zeros, p over q, would be 1 over 1, 2, 4, or 8. Not 48, 4 or 8. And if I were wanting to list them all separately, that's exactly what I'd do. I'm going to put the plus or minus in front of everything, so at least I don't have to list them all out doubles. I have 1 over 1, 1 over 2, 1 over 4, and 1 over 8.
That's a lot.
8 options this time, right? 4 in the parentheses, pluses or minuses doubles them. Okay, do you have a feel for what we're doing? Okay, so let's actually go to the question number 5, which occurs next, because I wanted to use the examples we already done because we have them. Here's the possible rational zeros, or we're finding the possible rational zeros of 8x cubed minus 36x squared plus 46x minus 15. And as wonderful as this equation all is, the only thing that matters is the 8 and the negative 15. Are you with me? So, my p-values, what are my numbers that divide 8? 1, 2, 4, 8. We did that one a moment ago. Fabulous. How about the numbers that, and we put pluses or minuses all the time, right? How about the numbers that divide 15?
1, 3, 5,
And 15. 1, 3, 5, and 15. So these are my p's, these are my q's. And now we're going to do p's over q's. So again, I'm going to put the plus or minus in front. So we have 1, 2, 4, 8 over 1, 3, 5, and 15. This one's a little different than the other two I gave you as an examples already because I have more than one value on top. My others only had 1. So that's going to make things sort of, like multiply out more. We're going to have a lot more choices. So to start with, though, again, I would put a plus or minus in my parenthesis. My math lab may make you list them separately. I don't know. I know they have a plus or minus button, but I just don't know if it's available to use on these particular problems. And we're going to start with just the first number, 1, and we're going to write that 1 over each of the other ones. So I have 1 over 1, that's 1. I have 1 over 3, that's 1/3. 1 over 5, and 1 over 15. So far, so good. Okay. Now, I'm going to go with the number 2. 2. 2 over 1 is 2. And then I have 2 over 3.
2 over 5, 2 over 15.
Yes.
Yay.
I'm just gonna mentally.
And then we're going to do, hang on. And then we're going to do the number 4.
4 over 1 is 4. 4 over 3. 4 over 5. And 4 over 15.
Now, if you had the ability to reduce any of these, none of these have so far, you would still reduce them too, all right? You would still reduce your fractions. Last one, 8, right?
8 over 1 is 8. 8 over 3. 8 over 5. 8 over 15. Now we gotta do all the negatives.
Yeah, Maxwell was very excited about that. And then, hey, I didn't make you write out the plus or the minuses of all of them, or you would have written out twice as many values, right?
Oh my gosh.
Okay, so there are actually 32 options. Okay, so raise your hand if you want to try all 32 options to see which one works.
Not me.
Not me either.
No.
So what do we do? Because that's kind of where this is supposed to be heading, right? I mean, like, what's the point if I write them all out, but I'm not actually going to try all 32? I mean, like, I might get lucky and it might hit on, like, the third one I try. That'd be pretty good in a series of 32 options, right? You might try the whole numbers first. I certainly don't really want to do the synthetic division with any of those fractions, do you? Not really. So what do we do? All right, well, I'm going to show you in problem number 6 what we do when we are actually faced with now what on these problems. We're not going to do it for this one. This one's really ugly. But we are going to do it for one that's a little bit cleaner.
Was that the answer for that one?
Yeah, it is. It just asks you to find all possible rational zeros, and these are all of them.
So, would you want us to write them all out?
The way that I wrote them here is perfectly fine. You would write them like that. My math lab may make you write pluses or minuses in front of each individual one, or it may make you write out all 32 of them. I don't know.
Oh my literal God.
But it also may not ask you one that has 32 options, okay? Don't be freaking out here. All right, come on.
My phone would be worse.
Maybe. We'll see.
Gosh.
All right. Do you like this equation better?
Yeah.
All right. Okay, we are doing the same thing on this problem. It's just an easier problem to work with, okay? It actually wants me to find the real and complex zeros, so the question actually leads me further down the bunny trail, but it starts out the same way. We're starting with the P's and Q's, possible rational zeros. So what are my options for P? Just one, right? Positive and negative. How about my options for Q?
1 and 2.
1 and 2.
Oh my gosh.
Yeah, I like this one.
Yes.
So P over Q is 1's on top and 1's and 2's on bottom. So I actually have the option of 1 over 1 or 1 over 2. Hang on. There we go. And pluses or minuses. There's still 4 choices, right?
Yeah.
Okay. So show of hands, how many of you have a graphing calculator that you have in class today? Okay, a handful of you. Not everybody does, but if you have a graphing calculator and or if you can borrow one from someone for the rest of this unit, like somebody down your hall or something, you will find it to be very helpful. Because here's what we're going to do. Those of you who have a graphing calculator with you, I want you to just put this equation into Y1.
Does anybody have a charger for a calculator like this?
If the same one as mine, I have a charger.
I'll draw the picture on the screen, so if you don't have one or just don't have it with you, you'll be fine. But it's x cubed minus x squared plus 2. Oh wait, that's not what I want to do there.
I gave that one to my sister for college calculus.
Okay.
And she decided to drop out of engineering.
All right, guys.
English major.
That's a big change.
So then she lost the charger. And I was like, hey, I need this for college algebra. And she was like, oh, okay. And I got it from her. She was like, oh, here you go. And I was like, where's the charge? And she was like, oh, I never used the charger. And I look at it, no battery life. I was like, ah!
All right. I'm going to sketch the graph on the screen for those of you who don't have a calculator with you. And I'm going to talk about why the graphing calculator is really helpful at this point in the problem and would be a time saver if you have it. So it's not that you have to have the calculator to do it. But if you don't have a calculator, you have 4 things to try synthetic division with. 1, -1, 1/2, and -1/2. Everybody with me on that? Okay? You probably don't really want to try all 4 options. What if it's the 4th option, right? Kind of thing. So it would be nice to sort of look at a calculator and know what you're looking at to make an educated guess as to where a good number to try would be. So this graph looks like this, kind of.
Oh, that's fun.
Okay? The location right here is the point of interest. You can hardly see that. It looks like -1 on my screen as well. Okay? This appears to be the place where it crosses the x-axis. That's what it looks like. Agreed?
Yes.
Okay. And maybe, depending on your screen, you won't be able to tell. Maybe it's like, well, it's either -1 or maybe it's -1/2. But at the very least, I think you can look at that and say, it's not positive. Right? And the fact that it's not positive eliminated 2 things for you to try. You do not need to try 1 or 1/2 because they're both positive, right? So at the very least, the calculator eliminated half of the things to try. It does look like it's at -1. So we're going to give -1 a try with our synthetic division. So we're going to do -1 on the outside. We're going to do our x cubed, x squared, x, and our number columns. Okay. So I have 1x cubed, -1x squared. I have 0 x's, and I have 2 as my constant at the end, and I'm dividing by a -1 with synthetic division. Okay? You guys have practiced this multiple times with me now, so we're going to pull our number 1 down. 1 times -1 is -1. -1 plus -1 is -2. -2 times -1 is 2. 0 plus 2 is 2. And then 2 times -1 is -2. Adding together to give me 0. Bam! We got the 0 that we were trying to get. That's our goal. So it did in fact cross at -1 on the graphing calculator. Okay? If it didn't, if you got something else at the end of this and you were sure you did all your arithmetic right, then you would try another one of your negative options, right? We would try, in this case, -1/2. Now, it's possible when I try both of them, I still don't get an answer. Like, that could happen. So I don't want you to always think you're going to actually get one that's going to be 0 at the end. It doesn't have to work that way. But if you don't have anything ending up with 0 at the end, it just means that none of the answers that you're going to get are going to be rational. It means they're irrational. It's still crossing the axis. I see it on the screen, right? It's crossing at negative something or other. But maybe it's like -2. Well, if so, the rational zeros test won't work because -2 is not rational. It's irrational, okay? So at this point, what do? Because we're not done yet. It says find all real and complex zeros. Well, we found one of our zeros. This number is a 0. Okay, so one of our answers is that x is equal to -1. I'm going to add my list up there as I continue to work. But there's a quotient that came out of this down here as well, yes? Yeah. It's x squared minus 2x plus 2. Remember, it starts out as x squared because it began as x cubed, 1 degree less. Now, we'd love to be able to factor this if it factors, but I can guarantee you it's not going to factor. And do you want to know why? My graph only crossed the x-axis one time. There's no way that I'm going to be able to get this to factor if it didn't cross more than one time. It can't happen. So now I need to use what?
Imaginary number.
It is the quadratic formula. Thank you so much. You're right, Cooper. Okay, so quadratic formula.
I was hoping I was wrong, but I felt it coming.
So x equals negative b. So that would be, what was my number? -2. So the opposite of -2, so 2 plus or minus the square root of b squared, so negative 2 squared, minus 4 times a is 1, and c is 2, all over 2 times a, which is 1. And yeah, I absolutely am going to get an imaginary number. I'm going to get a negative underneath radical. So let's actually see what happens. 2 at the beginning. All right, so I have 2 squared, negative 2 squared, which is 4. Minus 4 times 1 times 2 is 4 times 1 times 2. 8. Yeah, negative 8. All over 2. 4 minus 8 is negative 4. So what is the square root of negative 4? 2i. So this is now 2 plus or minus 2i over 2. Well, right, the 2 is in every single term, so it cancels them all. They all become 1s. So this is 1 plus 1i, plus or minus. Yeah, so you have 1 plus or minus I. Or you could write it as 1 plus I and 1 minus I. So I actually have 3 zeros. I have negative 1. I have 1 plus I, and I have 1 minus I. I can never have more zeros than the power of my equation. What was the power? 3. So the most zeros I can have is 3. I won't always have 3. I didn't say that right. I'll always have 3, but they don't necessarily have to be unique. Like I could have the number 1 3 times. That would be a possibility, and I'd have 3 zeros that just all matched. Okay. It's messy, right?
Yeah.
All right, we've got another one to try. Just one more. Just one more, okay?
Really like first night.
I'm sorry.
I like this one better than yesterday's.
You like it better than yesterday's? That's
I
good.
finally found a solution.
Hey.
to get out the test. It's called a bridge.
All right, step 1 is to find all those P's and Q's. All right, so grab your pencil, find some P's and Q's.
Yay.
P, Q. Somebody tell me my P's. I've got pluses or minuses already. What do I have? 1.
Can we slow
Or I guess
down?
I'm gonna go in order.
Can we
So 1,
please slow down?
3, 5, and then 15.
Okay, so these are all the numbers that divide the 15 at the beginning. 1, 3, 5, and 15, plus or minus. How about Q?
1, 2, 7,
Mm-hmm.
14. I know how to do this. Yeah.
Okay. This is a lot like that first one that we found the zeros for over here.
Oh.
I have 4 on the top, I have 4 on the bottom. Right?
Yeah.
Yeah, I do. So my P over Q here is plus or minus. I have 1, 3, 5, 15 over 1, 2, 7, and 14. I don't need to write them all out. That's not necessary. Okay? You know how to write them out, so if that were the question asked, you could do it, but that's not the question asked here. I'm trying to move on into synthetic division with a reasonable guess as to what my answer might be. Okay, so we're going to use our calculator to graph it and to see if any of the places where it looks like it's crossing match up with one of these P over Q values. That's what I'm looking for. So I'll draw the graph on the screen too once I get it, since I know that many of you don't have a calculator with you today. So 15x cubed minus 37x squared plus 44x minus 14. Okay, so if I just do a zoom 6, for those of you who are familiar with like a TI 83 to 84 calculator, zoom 6 is the standard window. It goes from negative 10 on the left to positive 10 on the right, negative 10 on bottom to positive 10 on the top. And that won't encompass all of these values, but it'll get awfully close. Potentially, I might want to go out to 15, because I do have a possibility of 15 over 1. That's my biggest possibility, right? So maybe I want my window to go out a little bit further. So I'm going to adjust it just for the sake of doing that. I'm going to go from negative 20 to 20, so that it'll hit the 15s, just in case it does anything out there on the far edge.
Wait, how do you zoom it to a specific number?
If you hit zoom 6, it'll go negative 10 to 10, negative 10 to 10.
Yeah, but how do you do it?
I hit window, and you can change the x min and x max. So I made my x min negative 20 and my x max 20 just to give me a little space on either side of 15. I end up not needing it on this graph because it doesn't cross that far out. But we won't always necessarily have that happen. This is a very uninteresting graph, by the way. If you graph this, here's what it looks like. I'm going to use the yellow. It's awfully ugly, right? Okay, so probably my negative 15 or negative 20 to 20 was not my best pick because it actually made it look tighter in. If I go back to my negative, hang on, Windows. If I go back to my negative 10 to 10 window, the way that I normally have it, it actually spreads it out just a little bit, and you can see that it looks like it's crossing somewhere between 0 and 1. Okay, but it's hard to tell when it's at a fractional value what fractional value it's at. Agreed?
Agreed.
Okay, so we're going to have to make an educated guess. I need to have something divided that gives me a fraction. So, like, 1 divided by 1 is too big. It might be 1/2. Potentially 1/7 or potentially 1/14. I mean, those are the things that it could be. I could do 3/1. That's not going to work. That's too big. 3/2 is also bigger than 1. 3/7. I mean, that's really close to 1/2. It could be 3/7. Again, 3/14. I can't do 5/1 or 5/2. But I mean, like, it could be 5/7, right? It could be 5/14. And then my 15 divided by nothing works. Now, the first thing, the one that would be the nicest, is if it actually happens to be 1/2, right? Agreed? So let's just try 1/2 and see if it works with my synthetic division. And I want to do a synthetic division with you with a fraction anyway, so you can actually see how it works. Because it feels a little bit different because there's a fraction involved. Okay, so my coefficients are 15, 37, negative 37, 44, and negative 14. And it really does look like it's roughly halfway in between. So the three numbers that are standing the best chance really would be like 1/2, 3/7, or 5/7. Those are the most reasonable choices. Okay? Oh, wait, just a second. Okay, everybody push pause for just a second. Okay, there's an error. We're going back and fixing it, though, because we can do that. We have a little time to fix it, too. Over here, this is the typo. That's why I was thinking it was wrong, and it was, and it's still wrong in my notes. I need to fix it for a little. Should say Q over P. I'm so sorry, guys. We're just going to flip all our fractions upside down. That's all we're going to do. It's all good. Okay, Q over P's. I promise you'll be okay, Cooper. I promise. Q over P. Q over P. So we did it on 1 and 2. So these should be flipped. All my values are flipped upside down.
I'm just going to put arrows.
That's fine. So it's 3 and negative 3. I'm so sorry. Y'all heard me almost stop before, right?
Yeah.
And I was like, wait a minute. And I was like, no, that's what I've got written down. I must be remembering it wrong. 9 and negative 9.
It's 2 over 1, so it's 2.
All right. These should be flipped. Over here, all these are flipped. I'm just going to star them and say that. Okay. And we'll go to the one that actually matters, which is the one we're on at the moment. They're flipped. They're flipped. Everything's flipped upside down. I'm so sorry. So sorry. Okay. These are flipped. Whoops, that's not where it was. Here. So the two numbers actually would be 1 and 2 if I flip them appropriately. If the last problem, the one that I'm on, I'm going to fix this part in the middle. So I have 1, 2, 7, and 14 over 1, 3, 5, and 15. Okay. So again, I mentioned that the ones that seemed most reasonable are the ones that are about halfway between. So I have a 1/3. That's about halfway in between. I have a 2/5. That's about halfway in between. 7/15 is about halfway in between.
I say we do a third.
So I think that would be it. Those are my 3 most viable options, and 1/2 isn't on my list. So pick one of the 3. 7/15. Okay, so Damaris picked 7/15, and she's going to be glad she picked that one. It is positive, for sure, because it's crossing on the right-hand side, right? Okay. So 15 is going to come down. And what is 7/15 times 15?
7.
It is 7. What is negative 37 plus 7? Negative 30.
Oh, hold on. Okay.
What is negative 30 times 7/15? It's negative 14. Okay, if you've got your calculator with you, you can verify that too. You don't have to do it by hand if you don't wish. What's 44 minus 14? Another 30. And then the 30 times 7/15 would now be positive 14, which adds to 0. Very good guess, Damaris. Thank you so much.
Damaris, you're only at least 700.
She gets the gold star for today. Okay, so go back to the directions. The directions said find all real and complex zeros. One of them then is 7/15, right?
Yeah.
I mean, that's it. It's 7/15. And I know that what I have after this has to be complex, imaginary, right? They have to, because it only crossed one time. So I need to take this piece then and figure out what I'm going to do with that. And as much as Cooper's not a fan, we are going to use the quadratic formula.
Oh my.
But before we do, there's actually something cool that happens. Oh my goodness, that's a very bright white screen. I got to get, how about this? You want a chalkboard?
Yeah.
Okay. We actually had at the end, what was it, 15
Maybe.
x squared minus 30x. What was next?
Plus 30.
Plus 30? Awesome. Before we start using quadratic formula with this, do you see anything that factors out of everything?
15.
The 15. So let's do that because it just means that I have a value that's going to make all of my calculations very large, but not give me any new information.
Would the 15 not be x cubed since it's under x cubed? Or is
Oh, yes. So no. So this is the x cubed column, x squared, x, and then my number. But when I have my quotient, it's always one less than what I started with. So x squared, x, my number, and this is a remainder. Yeah. Okie dokie. Take out a 15. I have x squared minus 2x plus 2. But I hope that looks familiar.
Oh,
What do you notice?
It's the same as last problem.
It is the same one that we did on the last problem. So we could do the quadratic formula again, but it will be exactly the same, right? We've already done the quadratic formula with this one. So from number 6, here we know that x is equal to 1 plus or minus I. Those are my other 2 zeros. Obviously, most of your problems are not going to just match from problem to problem. But if they did, be aware of what you're doing. Don't recreate the wheel when it's not necessary. So over here you have the solution of 7/15 and then 1 plus or minus I. Those are your 3 zeros. 1 real, 2 complex. All right.
Please tell me there's
That's it for today, Maxwell. Yeah.
You have a quiz tomorrow.
Oh, yes. Thank you so much. Couple of reminders then. Yes, you do have a quiz tomorrow over 3-1, 3-2. Over 3-1 and 3-2. Yep, this section and the last one. The chapter 3, the 3.1 quiz, the 3.1 written work quiz problems that you can bring with you to the test and so forth, so they would be helpful to just rewrite. All that's posted inside of Canvas, so make sure you have a chance to get those done. Point-wise, quizzes are worth more than homework, not tests. Quizzes are worth more than homework. So it's definitely in your best interest to make sure you get those problems done as a priority, even over the homework, although obviously the homework's important. All right.